Let's cut through the noise. You're sitting there in Cursor or Claude Code, right in the middle of a flow state, and bang, rate limit exceeded. Try again in 4 hours. Or worse, you check your API bill at the end of the week and realize you spent $40 just letting an AI agent spam git diff and build logs back into its own context window. Stop doing that. It's sloppy, and it's costing you real money. Right now, developers are obsessing over a self-hosted local AI gateway called OmniRoute. The headline claims sound like classic marketing clickbait: access to over 250 AI providers, 90+ free tiers, 1.6 billion free tokens per month, and up to 95% token savings using stacked compression. Most people see numbers like that and assume it's either fake or a security nightmare. So today we're doing a complete reality check. We're tearing down how OmniRoute actually works under the hood, benchmarking its compression pipeline, verifying those free forever claims against the real docs, and showing you how to set it up so your coding agents never hit a wall again. To understand why OmniRoute is different, you need to understand how your local environment communicates with AI models. When you use tools like Cursor, Claude Code, or Codex CLI, they default to pointing directly at a single vendor's cloud endpoint. If Anthropic goes down, or your tier limit resets, your entire workflow stops dead in its tracks. OmniRoute acts as a local proxy server running directly on your machine, typically listening on http://localhost 21.v1. Because it exposes a standard OpenAI-compatible API format, your IDE or agent thinks it's just talking to standard OpenAI, but OmniRoute intercepts every single payload. Once a request hits OmniRoute, 3 critical technical engines process it before a single packet leaves your computer. First, the fallback ladder. OmniRoute uses a 4-tier routing strategy. It attempts to drain your fixed subscriptions first, like Claude Code or Copilot. If you hit a rate limit or a 500 error, it switches in milliseconds mid-request to your paid API keys, then to low-cost models, and finally to free-tier provider pools. Your IDE never sees an error code, it just sees a successful stream back. Second, the 10-engine compression pipeline. Before sending your prompt to an external API, OmniRoute runs the payload through stacked compression engines like RTK, Runtime Kit, and Caveman. RTK strips repetitive, high-volume terminal output, like verbose git diff logs, test suite dumps, and build logs, by 60 to 90%. Caveman handles prose pruning, while preserving code syntax, URLs and JSON structures byte for byte. Third, agent-native protocols. Unlike older reverse proxies, OmniRoute includes a built-in model context protocol server, with up to 94 tools across 30 scopes, and support for agent-to-agent protocols, meaning autonomous agents can actually query the gateway to check remaining quota or adjust routing strategies programmatically. Comparative analysis: OmniRoute versus LiteLLM versus OpenRouter. Let's talk competitors, because you shouldn't just install every new tool you see on GitHub without asking where it fits in the stack. If you look at LiteLLM, it's built as an enterprise Python gateway. It's fantastic for production backends, managing Kubernetes clusters, or deploying Helm charts in a corporate environment. But for local agent setup, it requires heavy manual config and lacks built-in local compression. If you look at OpenRouter, it's a hosted SaaS cloud solution. It's zero configuration and ultra-convenient, but you're paying small markup fees, routing your data through a third party, and locked into standard context sizes without local pre-processing. OmniRoute sits in a completely different spot. It is a local-first desktop gateway running under an open-source MIT license. You get zero telemetry, full local key privacy, automated fallback across dozens of developer tools, and aggressive token compression during heavy agent coding sessions. The mentor's verdict: use LiteLLM for corporate servers, OpenRouter for zero-config SaaS convenience, and OmniRoute if you want local agent speed, total privacy, and maximum token reduction. Now let me address the claim that makes most senior developers roll their eyes. 1.6 billion free tokens per month across 90+ free tiers. Is this real, or is it math manipulation? I dug into the official repository methodology and independent logs. Here is the actual truth. First, pool deduplication math. Most multi-provider aggregators artificially inflate their token counts by multiplying rate limit ceilings across shared infrastructure. OmniRoute's documented count uses pool deduplicated math, meaning if multiple providers share the exact same underlying free pool backend, it only counts that shared capacity once. Second, the free forever reality. There are roughly 11 providers that offer genuinely free no credit card tiers, such as Coder, Pollinations, Cloudflare Workers AI, and Cohere. However, free does not mean infinite bandwidth. Many of these models have rate limit caps like strict requests per minute or daily token limits. Third, the compression factor. That 1.6 billion number isn't just raw API allowances, it accounts for how stacked compression stretches those tokens. If you compress 1,000 raw output or diff tokens down to 150 tokens before sending, your effective quota is 5x to 6x higher. The bottom line, you are not getting unmetered, high-speed Claude 3.5 Sonnet or GPT-4o for $0 forever without limits. What you are getting is a resilient safety net so that when your primary paid model rate limits, a capable backup takes over instantly, so you don't lose momentum. Let me show you how fast you can get this running in your own dev setup. Open your terminal and install it globally via node npm install OmniRoute. Once running, navigate to http:// localhost 2128 in your browser. Step 1. Configure your keys. Go to Settings, then Providers. Input your primary API keys for Anthropic, OpenAI, or Gemini and toggle on any zero-card free providers you want to use as backups. Step 2. Set up a combo. Create a custom fallback chain. For example, Tier 1 goes to your Claude Code subscription, Tier 2 falls back to your direct Anthropic API key, Tier 3 drops to DeepSeek or OpenRouter cheap models, and Tier 4 sits as your free backup pool. Step 3. Enable token compression. Set your compression mode to standard, RTK plus Caveman. This preserves source code byte for byte while stripping out bloated terminal logs and redundant prompt prose. Step 4. Connect your tools. Point your IDE, whether it's Cursor, Klein, Claude Code, or Codex, to base URL http://localhost 2128.v1 and use the gateway key generated in your dashboard. Let's wrap this up with a clear evaluation. Who should use OmniRoute? Solo developers and autonomous agent enthusiasts who run high-frequency coding loops and are tired of unexpected API bills or rate limit lockouts, privacy-conscious builders who want local-first security where keys and prompts never touch a centralized proxy provider, developers managing multiple tools who want one central control panel across all their coding environments, who should not use OmniRoute, enterprise dev teams requiring strict central identity governance, SAML SSO, and SOC2 compliance across corporate clusters. Stick to LiteLLM Enterprise or native provider gateways for that. Non-technical users who prefer zero-configuration SaaS setups and don't want to manage a local node process or Docker container. Stop letting rate limits dictate your dev flow and stop burning tokens on raw terminal dumps. Try setting up a local gateway, test the RTK compression on a heavy session, and see how much your monthly API usage drops. If you found this breakdown useful, hit the like button, subscribe for more deep dives into agent infrastructure, and drop a comment below letting me know what tool setup you're currently running. Peace out.